you have already understood about list and tuples in the previous video. So now let us discuss about what are sets and dictionaries. Now observe this property difference between list and set to make some understanding on this. So now when we come to sets, sets are unordered, mutable, and no duplicates allowed. As we discussed in the earlier video, now what is the meaning of unordered? Unordered means we cannot access the particular data structure through indices. We generally use sets because of its property called no duplicates allowed because we can filter out the duplicate items and get a unique items through this set. Just observe the syntax of set. I have just named the variable unique and under flower brackets I have given some elements like 1, 2 and 3 separated by commas. You can observe list is maintained through square brackets and commas, and whereas tuple can be maintained using just commas, but we use parentheses so that we can pack all the elements into one variable. Sets are constructed using curly braces. Now let us observe some code so that you understand what is the logic behind the sets. Now if you observe what is the difference between list and set. List is ordered whereas set is unordered. List allows duplicates and set does not allow duplicates. Whereas the elements of the list can be accessed through indexing, which is called ordered, gives the same meaning. But in set, we cannot access an element using their index. Why? I will say the reason in the end of this video. So now let's move on to practice program. You can see I have initialized a set which is mutable. Okay. Now what I will do is that I will just comment out this. Let us discuss about the mutable set first. Now, if I print A, as you can see, the output is set. And let me check the type of that. Type of A. That's set. Okay. Beginners generally do this mistake without knowingly because they don't understand the meaning of unordered at certain point. Now, let me clarify this because sets are unordered. That means we cannot access them through indexing. Now, you can observe when I print this here, we have initialized a set. Now, when I try to access this through index, like s of 0, that means it should be printing 3. But in case of set, it will give us an error where set object is not subscriptable. That means it cannot be accessed through indexing. Understood? Now, what if you want to change the property of set? As default sets are mutable, what if you want a set to be immutable? That means you cannot modify data after initializing a set. You can unlock this ability through frozen sets. You have a keyword called frozen set. Uh, think it as a function, frozen set, and you assign it an argument of set that you want to freeze. Right now, whenever I do this and print, you got a frozen set, whereas its class is frozen set. Right now, if you want to modify or change any data from the frozen set, you will not be able to do that because now its property is modified to immutable, right? Before moving on to that, I want to show you a unique usage of sets in our general programming world. Now I have initialized a variable called numbers where I am storing a list of numbers. Observe this. I am storing a list of numbers. As list allows duplicates, I have some duplicates in this. You can observe 2 and 3, we have duplicate numbers, right? Now I want all the unique characters or elements present in this list on a go. What I will do is that I will just convert this list into a set. A set has a property not allowing duplicates. It just throws out the duplicate element and keeps only unique one. Right? Now when you observe this, see that I pass this list into set where I stored it in unique numbers and just printed the unique number. I have got an output as 1, 2, 3, and 4, where it picks the unique element from the given list. Now, when we move on to methods performed on set, we have add, update, discard, clear, each subset, each superset. Now, let us discuss each one of them step by step. So, I am again initializing the set A, which is default set, not chosen one. When I want to add an element, I just add an element to set. I just do add and the number that I want to add into the set. As set is unordered, it does not maintain any order, so it can be added it anywhere in the set. It is not guaranteed that a particular element is going to be added at the start or at the end. So we generally do not prefer indexing in that. And then yeah, this was the initial stage of set. And when I run this, I'm adding an element 7. Then the current state of set becomes 1, 2, 3, 4, and 7. Right? Now, when I want to remove 1 from A, let me log this and just comment this out. Right? Now, when I want to remove 1 from A, just remember these keywords. If you want to add an element, just add, remove, discard, update. I will just discuss about this. For now, let us run this code. I want to remove 1 from A. Now, what will happen? This 1 will be removed and 2, 3, 4, 7 will be the output, right? Now, as you observe this, just also observe the discard function. When generally discard is used is when you want to remove an element safely. If you try to remove an element which is not present in the set, our Python interpreter is going to throw us an error. So we generally use discard function to avoid this error occurrence. Now, whenever we use discard, if element is not present in the set, it is not just going to throw us an error. It is going to return us the same set that we have, right? It is not going to throw us an error. If you observe this, when I do the same thing with remove function, we are going to get an error because one is not present in the set. So we generally use discard function to remove an element safely. As we have completed discard, now let me use the update set. Now when I update set A with B, that means I'm adding all the elements of B to A and printing the A. As you saw that we initialized a set called B with a frozen set, right? Now this frozen set and the default set are combined together to form a concatenated set A, which gives us output as 2, 3, 4, 6, and 7. Right? Now here comes the new concept. These are all basic operations that we perform on the list and tuples. But what is the uniqueness of sets? Set allows to do some mathematical and logical operations. Like you have already done some Venn diagram logics and all in your schooling. You might observe we generally use sets in that concepts, right? The sets of Python also work in a similar way where we can perform all the mathematical logics like union, intersection, difference, and symmetric difference using these sets. So these sets are so powerful to use in Python. If you don't know what are Venn diagrams and logic, you can just read this out. You will be understanding the logic between each operation. We generally use each subset function to check whether particular set is a subset of another set, right? Here we are checking whether A is subset of B or not. As you know, let me print the output. Let me print the current states of A and B. Print A comma B. These are the current values of A and B, right? Now A has bigger chunk than B, and A also have some values which are not present in B. So A is not subset of B. So it should give us output as false. Understood? Is subset false. Now when I try similarly whether B is subset of A, absolutely, because we updated set A with B, right? Now B is definitely going to be subset of A. So it should give us output as true, right? All the elements which are present in frozen set, that is B, are present in A. I will just show you the outputs of these Venn diagram logical operation. So yeah, this can be done using sets. We'll do some example programs using these super powerful operations, right? That will be so exciting.